Hi, I am Chandra and today came with a machine called Protostar. Protostar is a machine which contains a lot of executable files and we have to apply our reverse engineering technique. So I am starting with Protostar-stack0 executable file. So the source code for the stack0 is here and the machine is in the URL in this URL and the URL will be in the given description of my video. Now this is the source code. So there is a integer modified and the value of the integer is initialized as 0. Gettys is taking the input for the buffer, and if modified not equal to 0 then we will grab this flag, otherwise try again. So modified not equals to 0 means we have to put or get a true value for the modified value, as 0 is not a true value, so we will get try again. So I have already started the Protostar machine. Now it's time to log in with the default username user and default password is also user. So we are logged in from here, but I will use SSH and it's located in my programs. So PuTTY is a software which helps to connect from your Windows machine to a Linux machine using this software. So SSH port or Telnet or some other services. So the network configuration of this Protostar is it is connected to our VirtualBox host only adapter, and the host only adapters IP starts from 192.168.56.101. So 192.168.56.101, and I will open a connection. So warning, potential breach, the server host key doesn't match the PuTTY. Yes. So now I have to log in. So log in as user and the password for the Protostar is also user. So I have got a just simple shell, but there is no auto tab completion. So I will use a pon shell on the shell. So I will use a Python for it. So Python c import pty dot on bin/bash. Yes. Now, sorry. So we have just now got the Protostar and tab completion is also enabled. So the label is at optional Protostar bin/stack0. So I will go to that directory. So cd/optional/ Protostar, okay, /bin, and here I have got the stack0. Yes, here I got the stack0. So stack0 is located in here. So now I will try to run the stack0 file. So let's run stack0. Now provide some input string. Try again, as we didn't modify the buffer. So let's try again. Now we will start GDB, which helps a Linux machine to debug a C program easily. So GDB stands for GNU debugger. So gdb./stack0. So now it's loaded. So now disassemble main. So this is AT&T structure, but I prefer Intel structure. So I will set disassembly flavor to Intel, and now this is main. but as the source code is available to us, so I will check what is the starting point or the line number that is for the main. So I will check that the main or okay, so the main is at line 4, but I will set a breakpoint before the modified variable is going to check. So I will set a breakpoint. Sorry. So I will set a breakpoint on line number 13. So break 13. So a breakpoint is given. So now we will try to run the program. Run, and it's asking for input. So I will provide 4 A's. Now the breakpoint is got a hit. So I will use the info register to get know what's the status of the register is. So this is a accumulator, and where's the EIP? EIP is here. Okay, so info process map. So 0x, so 0BB is the starting address of the stack, but it's not getting copied. So this is our stack, and this is the starting address. So it's called, what is it? And the starting address is 0p. Sorry, I will just use the last 000. B double F E B double F E B. So just to make the font a bit small, we adjust here. So this is the starting address, and the ending address is 0x C 3 4 5 6 7, and this is the ending address. And here is so this is the starting of the stack, and this block or this portion is allocated for our the program. So from the EIP status we get that the EIP, or this is 0x8048 411. So this is 0x8048 and the EIP, this is the stack part by which we can access the stack. So stack holds all the temporary variables, normal variables, arguments, etc. That's we are passing through our program. So I will continue this, and as you know that we will get the try again message. Now we will run that again, and we'll provide 4 A's. Now it's time to check the 32-bit format or examine the memory in the 32-bit hexadecimal format. So ESP, and we are in the stack frame. So this is the offset, and we have to locate that where is the 4A. So we know, if you are not familiar with ASCII, then we need a manual, as I am not also familiar with ASCII. So user and user, so I will use man ASCII. So what's the ASCII? So 41 is the ASCII for A, character A. So here is the A is allocated here. So this is the, from this point the stack is getting started, and we know that the, for as a program is here, we know that the after the buffer we have declared modified, and modified is initialized to 0. So which 0 is applicable here, this 0 or this 0? So we need to find the exact address of the modified variable. So we will use info address modified. So symbol modified is a local variable and frame set of offset 92. So I will try to locate the exact address. So ESP plus 92. Yes. So the exact address or the memory location for the, that is 0B 4 times of F and 7 AC. Next we will try to find out what's the position of the starting of the buffer. So let's try with exactly 2, 3, 4, 16. So I will try to use info address buffer. Buffer is also at 28. So let's check that. ESP plus 28. Yes, we are exactly here. So from this position to this position, the total portion is allocated for our program, and we need to overflow this to get that, or to grab the message that you have got the modified variable or change the modified variable. So let's dig into that. Now if I continue this, I know that this will, so I'm just running the program again, and now let's know the exact address. So let's subtract that 0x b 2347 AC minus 0x b 76 C. So the size of the buffer is 64. Now continue and try again. So again running the program, and we will use total 65 is 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65. Now we need to get the flag of modified. So let's continue this, and we got the message, you have changed the modified variable. So quit this, and as here is no our read only permission, so we will go back to the home directory, and I will use nano, and I use exploit Python import p open and pipe p equals to p open. The location proto. So I need to confirm location. So this is the dot. Protostar. Slash bin slash stack0. Now stdin equals to pipe. Okay, now time for the equals to a of 65 pence. And we will get the payload. The payload. Now let's try to run it with changing it in the executable mode. So no match for p open. So I need that. So maybe there is something going wrong. Python p open. Okay, p open. I think p open. I think that sub process. Yes, I think sub process. Yes, I got wrong. Sub process is a here, and there I will get the p open. So I have included the wrong file, so it's not will be p open, it will be from subprocess input start. I think now it will work successfully. Yes, so we have made an exploit for that. So I have just changed the variable. So thanks for watching this video. Bye.